Good evening. I'm P. Madhav, lecturer in physics, in continuation of our video lectures, VSAQs for 12th class, part 3. Now in this, we got electric field and charges. In this we have got VSAQs. In this VSAQs, there will be one line answer, one or two lines or small problems will be involved in this. Now the very first question is, what is meant by statement charge is quantized. Charge is quantized means what you know? That is, charge will be Q is equal to plus or minus E. The charge will be in multiples of the charge of the electron. Charge will be in multiples of the expressed in integral multiples of the charge of the electron. That is, N can be Q is equal to charge can be expressed in terms of multiples of charge of electron. Now Q is equal to plus or minus Ne, where N is number. N can be E is charge of electron. N is equal to integral multiples, it can be numbers. It can be 1, 2, 3. Okay, this is very first question. And next, the second question is, in second, repulsion is the sure test for the true test of electrification than attraction. Why? Now, if you see, an uncharged body attracts oppositely charged body and also neutral body. There are two conditions like that. An uncharged body attracts a charged body attracts oppositely charged body or uncharged body. I'll repeat again. A charged body attracts an oppositely charged body or uncharged body, but always repels with similarly charged body. Therefore, repulsion is the sure test for electrification. So I'll write answer here. A charged body attracts an uncharged body or oppositely charged body. But always repels with a similar charged body. Okay, this is the answer. Therefore, you can write, therefore, repulsion is the sure test of electrification by attraction. By writing 2 mark questions, you have to follow that. Same question you repeat here. Therefore, repulsion is the sure test of electrification by attraction. This is the correct answer. Follow? The second one. Now, the third question is, how many electrons constitute 1 coulomb of charge. How many electrons constitute 1 coulomb of charge? Here, one electron charge, how much? One electron charge is 1.6 into 10 to the power of minus 19 coulombs. Okay, so 1 coulomb of charge, how many electrons? So you need to write like this, 1 by 1.6 into 10 to the power of 19. So number of electrons. So here we can take 10 to the power of 19 by 1.6, otherwise 10 by 1.6 10 to the power of 18, that is 6.25 into 10 to the power of 18 electrons. That is 1 coulomb of charge is equal to 6.25 10 to the power of 18 electrons. This is the correct answer. Okay, correct? Now, the next question. Now here, next one, fourth one. What happens to the weight of the body if it loses when it is positively charged? When it is positively charged. So here, positive negative means what? Suppose for example, electrons, sodium 281. By losing electrons, it gets positively charged. By losing electrons means it loses weight. Losing electrons means the weight of the body decreases. Weight of the body decreases. The weight of the body decreases when it is positively charged. Since what you can write? Since it loses electrons, since it loses electrons. Sodium example, you can take 281. One electron it is losing. So thereby what you are getting? Thereby it is getting positive charge. So positive charge means it loses weight. Okay. Positive charge means it is losing weight. Next question is, the electric lines of force do not intersect. Most important question. Next question is, fifth question. The electric lines of force do not intersect. See, electric lines of force, magnetic lines of force, they are of some properties are similar for them. See, these electric lines of force are open lines. Okay. Electric lines of force are open lines. Because isolated, you have got isolated charges you can have. The electric lines of force, positive negative means what here? Here, the electric lines of force do not intersect. Right? This is an important question. Intersect why? Now if we take positive and negative like this, they go separate. Positive and negative in that. Okay. We move from positive to negative. So in this, if at all they intersect at one point, there should be two directions. Okay. In materials, all that you find answer, but explanation will be only without diagram they say. But without diagram means knowledge wise it will be difficult for you to make you understand better. So here in my answer explanation will be a little wider, so you get benefited all the time. Okay. So at the point of intersection, there should be two directions, which is not possible. Okay. So if at all they intersect, answer, again the electric lines of force intersect, there must be two directions at the point of intersection, which is impossible. Okay, this is the answer. Diagram, yes. Explanation. Okay. Now, next question. Next is, what happens to the force? What happens the force between the charges if the distance between them halved? If the distance between them halved. Second one, B, doubled. Okay. Now here F is equal to 1 by 4 pi epsilon naught Q1 Q2 by D square or R square also converted. This is Coulomb's law. Now F1, F2, they are inversely proportional distance. R1 square, R2 square. What is saying first? Distance is A bit, distance is halved. So here R1 by 2 whole square by R1 square. So this is R. So F2 is equal to F1 by 4. This R1 square cancel. This is 1 by, here I will put one more step. Here F1 by F2 is equal to R1 square by 4 into R2 square. F1 R1 square. This cancel. Force decreases by 4 times. Decreases by 1 by 4 times. V bit F1 by F2, if you take like this, F1 by F2 is equal to R2 square by R1 square. This is doubled here. This is doubled. Doubled means 2R. F2 R1. Sorry, here not F1. Here F2 is equal to 4F1. Sorry. 4 increases by 4 times. So here it is double now. F1 by F2. 2R1 whole square by R1 square. We cancel. F2 is equal to implies F1 by 4. Decreases by 4 times. Decreases by 4 times, second case. Decreases by 4 times. Here increases by 4 times. Increases by 4 times. Okay, what is this question? A simple question. Carries 2 marks. Okay, 2 marks. Objectives. Alright. Now, the next question. Now, next question is one statement given. You have to explain about that. That statement. Electric lines of force do not form closed loops. They form closed loops. If they form closed loops, then work done moving a charge along a closed path will not be 0. will not be 0. So in that case, the above two statements, what is the nature of electrostatic? What is the nature of the electrostatic force? You know, when will be work done 0? When will be work done 0 means when the force is conservative force. The force is conservative, then the total work done is 0. Suppose gravitational force, the body projected vertically upwards, again coming down. One for work while going up negative, coming down positive. Total work done 0. It is called conservative force. So if the work done is 0 means in total path, it is conservative force. So what to confirm the two statements means here, I will write the question. Electrostatic field lines do not form closed loops. If they form closed loops, then the work done moving a charge, along closed path is not 0. The above statements what is the nature of electrostatic force? What is the nature of electrostatic force? Nature of electrostatic, here I told you, no, in a closed path should be working is 0. So it is nature of electrostatic force is conservative force. Total work done closed path is 0. This is electrostatic field. Okay. If they form, do not form closed loops. Okay, positive, negative is then particular. This is answer by this. Next question. State Gauss law in electrostatics. State Gauss law in electrostatics. That is, E dot ds is equal to the electric flux. The total electric flux through a closed surface is equal to 1 by epsilon naught times the charge enclosed by the surface. That is the Gauss theorem. Okay. So, the total electric flux enclosed electric flux through any closed surface. Is equal to 1 by epsilon naught times the net charge enclosed by the surface. Equal to 1 by net charge enclosed by the surface. Okay, where epsilon naught is the permittivity of free space. Okay, this Gauss law is a method to find out the electric field intensity near a linear conductors or conductors having arbitrary shape. Is easy method of finding. Suppose if you go for general methods, to calculate integration and use, the process become very complicated to calculate the electric field outside the charged bodies. So this is a simple method. Just you have calculated net charge enclosed by surface, positive, negative. You have to consider the magnitude. Divided by epsilon naught will give us the electric field. Okay, easy way of finding it. Okay, so these are the things that we have, and 3 more questions are there. In the next video, I will continue. Till then, thank you.